Okay, I'm gonna grab some water and then we're ready to start. Okay, so hello everyone and welcome back to yet another live coding session where we look at where we implement an HTTP server in Odin. The last time around we started porting our ePOL implementation of the HTTP server to IOU ring, and we had to write a lot of the bindings. I mean, we had this example from the HTTP server that has already been written in Odin that we could kind of make have a cross reference and see what they did. But basically it boiled down to me writing some rewriting the C header in Odin. Exactly, and then we tried and test the setup function. It worked. At least I hope so that it does. Today we are gonna look actually off stream. I continued the implementation and implemented the submit to the submission queue and the completion and the read from the completion queue in the IOU ring, basically from the example that was provided from the man page. And today we are gonna get something to work, hopefully, with IOU ring. This is gonna be a stream where I won't look at chat. So I'm gonna be just me programming. Let's see how it goes. Okay. So let's switch the scenes. Switch the scenes. Okay. Personal HTTP tmux. So what I did off stream is the following. These two files can be deleted, and this one as well. So we started last stream porting or writing the bindings for the IOU ring API in Odin. It basically involved me changing the syntax and adding some flags fields, and off stream I added some of them as well. So I think most of them are in here by now, but some may be missing, like this flags field has not been ported yet. And basically what I did was last time implement the setup that is calling sys IOU ring setup. Then we initialize the IO ring that basically consists of a submission queue and a completion queue. I think I will redo this here, but whatever. And it has so we had to memory map what do? We memory mapped the virtual address space that is in kernel space to our user space. so that the kernel and our process share the same memory. We did that for the submission queue and the and set all the things that we need. So the tail of the submission queue, the head of not the head of the submission queue, but the mask, the flex, and all the entries. And the same thing for the completion queue with the tail, the mask, and the entries. And then we return. And when we have an error also, we just return the error here. Okay. So this is what I implemented off stream. This is submit to the submission queue. All it does is it reads in the mask. So we read in the entry that's currently the one that should be polled by having the tail index and the mask. That comes from the IO ring. Then we set all the parameters that are given by the function caller. We set the address, which is the pointer to a buffer, the length of the buffer, some user data so that we can refer to the submission entry when we get the completion, opcode, and then we make an atomic store to the tail, basically making sure that, hopefully this ensures that, wait a second, where submit to SQ, making sure that these writes here, they're all sequentially consistent, and then we check if the IO ring needs a wake up. After a specified amount of time, the kernel thread will go to sleep. So it's basically spins and reads and checks whether the head is equal to the tail. And after a certain amount of time, it just goes to sleep. And then we have to wake it up again. So we do that with SQ wake up. And yeah, that's basically adding. Read from CQ. Here we basically have to do the exact opposite thing. Here we have to get entries from this from the completion queue and not put something on the queue. So we have to read from the head, but while the head is equal to the tail, we do pause, telling the CPU that that this is a spin loop. We read the tail again. I don't know if this has to be atomic here. Maybe it has to. But I don't know. Yeah, then we get the entry from the completion queue with the head index and the mask, and then we store head +1. So we tell the queue where the current position is. So we advance the current position. And yeah, I don't know if this works. So the next step would be to go into also. One second. What I also did is try to find these intrinsics. Fence, not fence, it's pause. And this is for signals. I'll try to find the x86 pause instruction, or the intrinsic for that. I didn't really find it, so I had to basically write an assembly file with a pause function that does nothing but pause and ret. I don't know if this works, but I hope it does. Maybe we have to inline this. Overview, force, I think it was force inline. Yeah. We can try that if that works. Force inline. Maybe force, use force inline. So that we don't have a function call here when we call pause. And yeah, that's that. So I had to write this assembly file, expose the symbols, and then I have to make a foreign lib or foreign import. Make a foreign import and tell the, I don't have to do that if the name is the same, but I omitted that underscore here. So I said, okay, in the assembly file, this is named underscore pause. We call this with the C calling convention, and this is externally defined. So yeah, and then I can just have the assembly file there, and everything hopefully works. Yeah, so next thing would be to go into HTTP Linux and server loop IO uring and get everything working, get everything together and see if it works. So we got this set up with a ring of D. The next thing would be to probably add to the submit to SQ. It's IO uring dot submit to SQ with the ring. With the ring submit to SQ. The ring, the file descriptor, the op, buffer, and user data. So ring, this, okay, accept doesn't require a buffer, right? So yeah, that won't really work, so yeah, whatever. So the server socket, and I believe we have to cast this to a Linux file descriptor. The next thing is the opcode, which is IO uring op, I guess, and it's dot accept. And the next thing was the buffer. Probably just nil the length and something else. Was there something else in there? Submit the user data. User data, probably I had a -1 somewhere, -1 U32. Let's just use that. Okay, let's submit to, no, it's in HTTP Linux. Submit -1 U32. Okay, that will be a submit call. Hopefully that works. Just see it. Let's just see. So this can return error. Errno equal to this. If errno is not equal to .none. Println unable to submit to submission queue. I'll have to submit accept call to submission queue. Okay. So this would be that. And then we would have just a spinning loop that would read from the CQ with the ring. And what does it need as well? Does it need anything else? Read from CQ. No. Okay, this returns a IOU ring CQE. So this is CQE. Then we have to check if CQE dot res is less than 0. Then we have a problem, right? Or maybe we have to first check what the user data is. So if user data is equal to -1 U32, so that's our server socket user data. Let's just call that server socket user data. Server socket user or negative server socket user data. Okay, so if it's a server socket, then it was an accept call. I don't really know what accept would do. I mean, the res in this case should be the file descriptor. So res cque.res should be a Linux file descriptor, right? At this point. So this is the client. Is that correct? When we call accept, yeah, this gives us also an end. So this is the client, and the next thing would be to submit again, but now we want to submit a read. And read from the client socket or client FD. But now we need a buffer. So we need to pool acquire con pool, I guess. So this would be the con IDX. And the connection, the con is equal to con pool dot is used, and then con IDX. This is the con IDX, and I think pool acquire. Oh, it also needs, no, it needs a client socket. Okay. Needs a client socket. So this can also get an error. Pool error. If pool error, we have to do something. Assert not pool error to do. And do this. I mean, probably we just close the file, so we could do something like if pool error dot close client FD. Continue. Okay. If not, pool error, do it like this. Okay. So this would be, we don't really need the, oh, we need the connection, right? Because we need, this is the client FD. We need to fill in the buffer, con idx dot parser dot buffer. Is it like, what was it that? It was parser, let's see. I think it was parser, HTTP parser, was an HTTP, right? HTTP parser. And we need the parser buffer. Parser dot buffer. So it's con dot, so con is equal to con pool dot used con idx. Good. Already had that here. Okay, so we put in the content parser buffer with a read. Do we do check whether we have to check how many entries are in the queue? Or whether we are overriding entries in the head. So this might be, yeah, this is something we haven't implemented. How do we know that this thing is full? Yeah, this is something IO ring submit to SQ to do check whether the submission queue is full. And for this we also need the head. right? So head is also a pointer to U32. And in setup, we also set the head 26 down. Result.searing.head transmute pointer to U32 from a uint pointer CQ pointer plus uint pointer params.CQ off.head. Good. Okay. So I believe it would be like this. Xcalidraw. So I guess when we have the queue, we have a head. We have a head and a tail. We, as the submitter to the submission queue, we write something into this slot here, and then we say tail plus equals 1. So tail will point to this slot. But at some point, when we are here and try to increment, we get to the head. And we have to distinguish, and we cannot just do that, because how do we distinguish empty from full? So empty is tails equal to head. But full probably is tail is equal to head minus 1. So we cannot use that last slot, I guess. The IO rank submission queue full. Overflow. The overflow queue needs to be processed eventually, so we update our flush function described in callbacks and context. So I don't know if I have to check this. So the rest said, yes, this app will overflow the commission queue. Normally an application would ask for a ring of a given size, and the assumption may be that this size corresponds directly to how many requests the application can have pending. Let's look at this. One thread is responsible for keeping the submission queue topped up. The other thread reaps completion queue events. This is like to overflow completion queue. Could also look at this here. Another setting is that there are two possible solutions. Setting the IO ring setup CQ no drop flag will, by to quote Jen Expo, change the behavior a bit for CQ ring overflows. First of all, it doesn't overflow the ring and simply stores a backlog of completions that we weren't able to put into a CQ ring to prevent the backlog from growing indefinitely. If the backlog is non-empty, we apply back pressure on I/O submissions. Any attempt to submit new I/O with a non-empty backlog will get an e-busy return from the kernel. This is a signal to the application that it has backlogged CQ events and that it must reap those before being allowed to submit more I/O. I wonder if we can also, I believe we can't really overflow the submission queue, right? But we probably can overflow the completion queue. So call to IO ring enter will return e-busy. Yeah, but we don't use that. But what about the situation where we are using a kernel thread to pull the submission queue? In this situation, we're not calling IO ring enter, so we'll never see the e-busy error. I assume that the solution here is to call liburing's IO ring CQ has overflow before attempting to submit anything to oh, 1 second. So IOU ring CQ has overflow. So liburing GitHub. Let's look at IOU ring CQ has overflow. Is there something? Oh, I'm not signed in. Are you kidding me? So let's go here. Let's git clone git https slash liburing GitHub expo liburing c liburing rip and then IOU ring CQ has overflow. Where's that defined? IOU ring read once. SQK flags. Okay, so there's a flag in the S ring. Let's see if we already have that here somewhere. Because I have flags. IOU ring SQ flags. SQ flags. Oh my goodness, SQ flags. Okay. IOU ring SQ bits. Where did I define that? IOU ring SQ bits. Oh, there. CQ overflow. Okay, we already have that. CQ ring is overflown. Okay, so we just have to check the flags. So in submit, at the top, we just have to say ioring.sring.flags. I don't know if this has to be an atomic load, to be honest. I don't really know how the Odin compiler knows what memory is what memory is shared between the processes, and how it knows that it should not optimize these moves out. But okay. Let's just make it an should we make it an atomic load? Should we atomic load when using shared memory? I mean, in C we would do something like volatile, right? Okay, I believe we should. Also here do that. So let's say flags sring flags. There's an atomic load of this also. So I'm not too sure. This shouldn't really change, but I mean the mask shouldn't change, right? So let's use the string flags here as well. And let's check if dot CQ overflow in string flags. Then we say, okay, we have to return something, right? And we return an error now. So is there an e-busy? Man error now dash l. Oh. I thought this would work, so let's see, is there an e-busy? Yeah, there is an e-busy, so let's just return that. Error is equal to Linux linux.err now. No, it's equal to dot e busy return. Okay, so that way we can ensure that. Let's just see, let's see if the build's even. Okay, this is server socket user data of type U32 to U64 and procedure argument. Why does it have to be U32 though? I64, U64. So now it doesn't like that because, okay, in epoll, let's see. Epoll event. Include Linux epoll. Oh, or is it sys? It's sys. Include sys epoll.h. And let's see struct epoll event. Epoll data. It can also be a U64. So let's make this U64. U64. Read from CQ. What was the error? Undeclared name, read from CQ. Read from CQ. Oh, it's io urang dot. I thought pool acquire would return an index and an error. It does. 2 equal 1. What? Assignment count mismatch. Let's see. Odin build dot con idx con index. Why doesn't that work? Oh, this is kind of a weird error. Let's note that. Let's write that down actually. Or how do I forgot how I do a screenshot. Odin error assignment mismatch when typo in function name. Let's see. Let's copy this. I mean, this shouldn't really, this is kind of a bad error message. So it should be acquire. And that fixes the problem. So client FD to TCP socket. So con IDX, okay, make it a U64. Any sockets. Oh. What? No. I thought this worked. Why? Is it because there was a line in between those two? Missing.node.gnu stack. This worked before. I'm pretty sure it worked. This is a warning. Why does the warning come up here? But does it still compile? Yeah, it seems so. Okay, I don't know. Okay. So next thing would be to, so if it's not the server socket user data, then obviously it has to be a client socket. So the con IDX is equal to, no. First thing, check this. If the client FD, no. So client FD can be -1, CQE.res. So if CQE.res is less than 0, also 0 probably can't happen, but I don't know. We don't want to do this, so we have an error. Let's just error while accepting on server socket. I mean, we could just say, I don't know if this can ever be I mean, it should never be 0, right? Can an F file descriptor be 0? I already Googled that once. So that should never be really possible, but whatever, we just leave it like this. So when we have that, or we could just say, no. Okay. We acquire connection, we set all this, we did the overflow check. If we have an error, we cannot put this into do we just close the connection? Probably. So should we close the connection when our CQ overflows? I don't know. So if errno is not equal to none, we just say whatever net.close the client net. Should we use net.close? We could also just use Linux close here. Then we don't have to cast this the entire time. Linux.close. Yeah, that does exist. Takes the Linux file. Okay, great. So don't use net.close, probably. So linux.close client fd. And linux.close client file descriptor. I want to test something, and so when we say pool init, I want to pass in a type. Something like this. I don't really remember how this works. They call it parametric polymorphism. Parametric polymorphic. Here, this type. Okay, so connection pool init also now gets a FD type, or more like FD type, which is a T. No, this is a dollar type ID. Does that work? Oh, no, that's wrong. Has to be on the struct. It has to be on the struct. But how do I use that in a function? I wonder. So connection pool. This has now an FD type ID. Good. When intrinsics, that type is integer. Where? Oh, there's also where clause. N is greater than 2. Okay. So where? I don't know. Let's just. No, this is also wrong. So this has to be. Now, how do we instantiate this? With foo tn. So we have to do this here, right? On the connection. So here there's a type, FD type. This is the FD type. And this gets also an FD type ID. And this is the FD type. Does that work? No, without the $sign, right? Expected comma got end of file. That's not good. In Linux. Okay, so 176. Oh yeah. Connection pool and variable. Invalid use of polymorphic type. Invalid use of polymorphic type. That's kind of weird. I thought this would be the right way to do this. Oh, did I do it on the wrong thing? Client connection. Oh yeah. We're still in there. Oh, this also has to have this. So FD type. And do I have to store this somehow? Because now I wonder if this is still possible here. Connection pool linux.ft. Did my system just crash? Hello? Oh, my system didn't crash. But something did crash. Tmox. How do you... So I unfortunately stopped the stream for some reason. That was kind of great. So what did I do? Tmox list sessions. Man tmox delete remove delete session. How do I remove tmox remove session? Kill session. Tmox kill session 0. Session name. Man tmox kill session. It's not even in here. Man tmox kill session. Kill. Too many arguments. Needed most 0. Tmox list sessions. No server running. Okay. Personal HTTP tmox. Good. Go here. Go here. Make. Okay, that did work, right? No. Does NeoVim just crash? No, the build is just hanging. Why does the build hang? What the heck? So for some reason, the build just breaks. Okay. I don't know why though. Look at this. So, is it a good idea? Is it a good idea to have this? I'm not sure. Okay, so now it shows errors again. Maybe it was because we had this thing here. But it seems like it wasn't an infinite loop. infinite loop with parametric polymorphism on functions. Okay, let's just note that down. Okay. Let's just write that down. So what is the next error? Pool of type connection pool has no... I mean... What? How do we pass this around, though? How do we pass these things around? Has no... What? Does it need something? What? Undeclared name T. So it wants that. Do we have to pass that around each time? Can determine polymorphic type from parameter connection pool 153. Oh shit. Con pool. This is con pool init. No, where do we init this? It's in pool init. So connection pool Linux file descriptor. Pool acquire. So we have to go to pool acquire. This has a T now. Shit, okay. Oh my goodness. Was this a good idea? This was no good idea. No good idea. Why does it not have an FD? So why does it work here? Why don't we need this? Doesn't make any sense. Why do we need it there? Connection pool has no field. Free length. Is it the using? Are you kidding me? 64. Apparently it has no free length. Don't know why that is. Why does it have it there? Why does it have a free length here? It doesn't make any sense. Why does it have a free length here? I'm pulling it. I have no idea. Pull acquire. Oh, okay. I think we're onto something here. Pool acquire should be a T. Right? But I don't think that this works like this. I don't think that it works like this. Expected one expression on the right hand side. Oh. Redeclaration. So this would be the same FD type, but does that work? Okay, so that works. I guess. So that's in 55 and 55. Let's see. Client. Okay, we didn't accept here. That's kind of a little bit shitty. We're in a shitty position right now. We could just make this an int. We could just make this an int, but we can also do this. Server sockets. This is a net.tcp. No, this is a linux.ft. And linux.accept. Let's see if we can get this to work. Linux.accept file descriptor and errno. So this is the client and this is the accept error. Good. Pool acquire with a connection pool. Okay, let's see if there's anything else that's standing in our way. Linux accept parameter adder of type. Okay, shit. I have to go pee, get myself a cup of tea, and come back. Okay, so man, except it probably gets a sock adder. Let's look at man socket. There was an example here. Man socket to no sock adder. I think it was inet, right? Yeah, sock adder. Sock adder. Depends on socket flags. Socket flags. Oh man. Adder length. Oh god, okay, so except client adder sock. Do they have that? Sock adder inet. Sock adder inet. This is Linux. Sock adder inet. Pass in a reference to the client adder and a 0 for the flags or something like this. We're completely sidetracked at this point. Okay, so this works again, I guess. This is a client connection. Let's just say client connection is client connection linux.fd and connection pool is connection pool linux.fd. So this would be a reference to a connection pool. Let's see. Redeclaration. Okay. Let's call Linux client connection. Linux connection pool. Linux connection pool. Okay, then in our main, we say this is a Linux connection pool. Client connection. This is line 83. This is a Linux client connection. Client connection has no field parser. Oh my goodness. Uh-oh. We should not have done this. This was a mistake. Now we have to add that everywhere, I suppose. Okay, here it's already. And now it hangs again. Why does the compiler hang? Hangs. Oh man, this is bad. When I rename this to T, it works. Oh man, what? I mean, is this my machine or what is happening? What is happening at this point? Why does it hang all the time? Man, we should have not done this. Sometimes it hangs, sometimes it doesn't. I have no idea. I have no idea. Okay, so go back into this. Receive TCP. We now make this linux.read client socket into the buffer. Should be the same thing, right? Why does it hang? Come on. Why do you do this to me? I don't even know what is hanging. And what causes that? What causes, like, if I remove this? Is there any state here? No, I don't think so. Let's try and compile this again. No. Is it? What? This is kind of unfortunate. We could also do something like fd is Linux fd type, something like this, and then have that here, so not in here at all. I wonder if that causes the issues, but I believe it does. FD type. Okay, remove all of this shit. This is FD type. We don't need that. We don't need this. I think this should just work. Yeah, so now it doesn't hang anymore. That's great. Free. So what make? So something is weird with the parametric polymorphism. Maybe it's that, but I don't really know what else could cause this error. Okay, why is this a problem? Send TCP, so this would be a linux.write. Oh no, this is a... Oh no. This doesn't work. Let's just say, okay, here, this is our send. TCP is just linux.write. So this is send TCP. This is also, again, this. Okay, good. So I don't know if this works. Let's just see if the epoll version works. What? Socket? This is a linux.fd. Okay, so init socket should return a linux.fd. For now, so to do use the POSIX API to set up the socket. For now, we just say, okay, this is linux.fd. Socket net, socket linux. Okay, this doesn't really make sense that we did that, but so, and now I don't even know if this works, so let's see. Okay, at least no error. index.html runs. Localhost, let's see, we have a connection. Okay, so it still works. After all of our refactoring, that could have broke something. I just told you. What exactly made it crash? Oh. I believe there's still the bug. There seems to be a bug still involved. Uh-oh. What happens? Request entity to large. Backtrace. Huh. Or request entity to large. Oh, this is a different error. This is when there is nothing to read. Epulse loop. For read is 0. So previous offset and offset are 0. Now we probably, so when we go into handle connection, this is a bug. Handle connection. Oh yeah, nothing was read. Right response, close. Why does it lead to our server crashing though? Probably because the write fails, right? And we don't handle that error. It's probably because of that. Probably because the write fails. Is that true? So let's break at write response. Now, does it also break if we just open this, close it? Okay, so that's actually something we can reproduce. That's good. So let's actually break at break http.odin, and then let's remove this using here. Con.writer, that should all work. Con.response, con.writer, con.response, con.writer. Okay, con.writer and con.writer buffer. Good. Client socket, con.client socket, con.client socket. Okay, break HTTP Odin 333. Run. Okay, right. Stopped. Why did it stop? Why exactly did it stop? look up status code. Oh no, we have to recompile this. So it's still the same line. Stopped. Why is it stopped? Process stopped. Stop reason. Oh no, that's correct. Okay, we iterate through all of these buckets. Yeah. Okay. We should have. Oh, okay. Quit. Okay, break. Let's break here. So 3, 4, 6. Run. So send TCP. Signal pipe. We should handle this error. So send TCP. Oh, maybe this just returns Erno. Erno. So Erno is equal to this if Erno is not equal to none. Return. Same thing here. Okay, so let's rerun this. No, don't rerun this. Quit. Let's actually recompile this. And let's see. Okay, group. Send TCP. Linux.read. What does that return? Linux. Not right. And int and erno. Okay, so this would be bytes written. Bytes written and whatever. You don't really care about the bytes written. Missing return statement. So does that help? Write response. We just ignore that, right? Let's just run this. No, still. Sig pipe. Oh, if we write to a socket that has been closed, we get a sig pipe. How to avoid writing to a socket that has been closed. Didn't know that. Okay, let's ask Gemini, how do I recognize that a socket has been closed before I write to it so that I don't get a sig pipe signal? Should we just ignore this? Oh, okay, I can use send. Okay, so let's actually define send TCP here in GP Linux. Linux.send. Send to adder. Ooh, needs the adder. Send. Destination address. Why does it need a destination address? Why does it not have send? Send no, okay, send no adder. Okay, that's something. You can use that. So this is, let's define send TCP as a proc. That gets a linux.fd. It gets a buffer and flags. A buffer Send no header. And flags. So buffer. Yeah, no, it doesn't get flags. And then we do linux.send and result is equal to this. Or something like bytes written int and erno linux.erno bytes written and erno return linux.send fd buffer, and now we need this here, which is, I hope that there's a message no signal dot no signal redeclaration of send TCP. Okay, let's see if that does something. Hey, it works. Okay, so this is good. Probably this is because we migrated. This might be due to us moving away from send TCP. Yeah, might be true. I don't know. If we would use net.send TCP, it probably would have set this flag, but I don't know. So that's good. Let's go back to our, so we were sidetracked a lot. It's linux.close. Is there another net.close? Net.close? No. Okay, so in our server loop IOU ring, let's see. So if the user data is not server socket user data, we have to read, and that can only be accomplished. No, we need the con IDX. We have something to read. So we need the con IDX, which is the user data. So cque.user data. Then it's probably U32, right? Maybe, I don't know. Then we say con is equal to con pool.used and con IDX. Now we want to handle the connection, but only if there is something to read, right? So let's look at the server loop epoll. So we don't need that. Linux to read is not equal to .none. So we have to check if cque.res is less than 0. It's greater than or equal to 0, and then we just copy all of this. This is cque.res. Handle the connection. Don't delete this. Don't do this. Connection reset, pull release. I think this is what we want to do. Next thing, if that's less than 0, we want to do this, I guess. Let's look. Yeah, I think that's that. Oh, client con. No, can't pull. Con IDX, U32. Question is, does that work? I don't believe that does. See, we got something going on here. Send TCP. Now this is the thing, send TCP needs the ring. Okay, it does work. What? Oh, HTTPS. I'm surprised that it does work. Should we consider moving the right of the response to the ring as well? If we do that, we have to, if we do so, we have to check in our server main loop that the CQ completion queue entry comes from the right, or maybe there is a way to or to not have a CQE for the right SQE. But I don't know that, so it seems to work. Finished port implementation of IOU ring based IO. Oh, this thing follows me again. Camera, that is pretty annoying. So that's nice. I did not expect this to work because I basically copied over from the header file to my bindings that I hand rolled, and I would have expected that there's something wrong with that, but apparently it works. Let's just see if it also does does work if we have a connection open. It does. This is great. Now the thing is that I really would like to put the rights also on the ring. The problem is we call this from the platform agnostic code. So what we would have to do is have a global IO ring, which is an reference to, or an IO ring, and then set that reference, or set the IO ring, the global IO ring, and then use it here. But then we would also have to somehow avoid that a completion entry is created on the completion queue. So some trade-offs to be made, right? One second. So the next thing I want to do is make a profiler and look at what is faster, our ePOL loop or our standard server loop, our IOU ring loop. And yeah, we would have to build a profiler for that. But I think I will turn off the stream for now. I hope you enjoyed the stream. Leave a like and subscribe if you want on YouTube to miss no upcoming streams. And